let's go. So yeah, so in the last video we got this question a little wrong. We didn't explain it saise. So we've drawn the diagram saise, and hopefully Imad can convey what you're actually supposed to do.
So in the first isomer, what we have is we have the H2O being opposite each other over here, the black line that I've drawn, and the Cls being opposite each other. This is basically a trans isomer, right? Because they have them being opposite. Yahan pe, that's one of your isomers. The other one, you have the opposite ligands being different. So yahan pe H2O ke opposite you have Cl. Yahan pe H2O ke opposite you have Cl, and yahan pe H2O ke opposite you have Cl. So this is a cis isomer. So those are the two isomers you get from this.
Trans.
Yeah.
No, this is cis, and which one's trans?
Cis. This is and that is trans.
Yeah, and as Ali pointed, if you could just rub those black lines, because I can't. And as Ali pointed out, a nice way to look at it is just to keep one pair of opposing ligands as just constant, unko ignore kar do, and then you're just left with two pairs of opposing ligands, which you can just have simple cis trans with, which is basically what I've done here. Because if you just ignore the brown line, the Cl and the H2 ke brown lines ko chhod do, so you can really just look at the blue line and the orange line, like the two Cls opposing each other and the two H2Os opposing each other, and how we've just switched one of them to give you cis trans isomerism. So yeah, I think we're good with that. So let's just continue.
Comment below if you think further explanation is required.
I'm not that big on explain anything, but why not?
Comment, I didn't get it. Sorry.
Comment your probability is.
I didn't get it. NCFP mein ho gaye. Someone laughed.
Anyway.
Okay. No, you shouldn't make NCFP jokes. Very insensitive. Okay.
They're human too.
Hey,
Okay,
you can't joke about the fact that they're in NCFP when you're teaching at NCFP. But and they're right, because I did joke about it and it didn't go too well. Yeah, so you go from ethanol, which is basically CH3 C double bonded O, which thoda messy ho gaya, and H, so you have an aldehyde. Diimmerses in an alkaline solution according to the following equation. The initial rate of this reaction was measured starting with different concentrations of CH and OH. OH obviously is a reactant because you have the alkaline solution, right? And you have to deduce the orders. So pretty simple. OH either constant hai, so that's nice, because now we know whatever happens here and what will only be dependent on what the change was here from this to this, basically, because OH is constant. So this is going.
And you can see both of them doubling.
Yeah, both of them are doubling, which means the order of reaction is first order. So yeah, reduce the order of reaction with respect to OH. So let's look at it here. Either now since either constant.
Yeah, let's look at 2 and 3.
Yeah, so 2 and 3, and either so like you won't always get a nice clean thing where either like these two would be constant. So either dono change ho rahe hain, like both the OH and the CH3CHO. So here this is going into 2. Sahi hai. So because of that, this should go.
This is 2x. Let's make it 2x.
Yeah, you can do it like that. Let's hold
0.2 to 0.4 is like 2x.
Let's do with that method in just a sec. पहले ये बड़ी तफरी वाले जुगाड़, like देखो, CH3CHO is first order ना, तो अगर वो double हो रहा है तो this should also double, so it should go from 2 to 4. सही है. Now that this is also doubling, and the rest that it's needed, ये भी double हो रहा है, तो ये भी first order हो गया. And another more formal way to look at it is what Ali was suggesting. So Ali, if I am not wrong, I believe you were suggesting कि आपने इसे 2 plus 2x is equals to 4. Was that it?
2 times 2x.
Yeah.
So
Although,
4x equals 4, and you get
yeah. And the reason for that is because you know this is going into 2 and you know that that is first order. इसका आपको order नहीं पता तो आपने उससे x कर दिया and you multiply them and this was going into 4. So those are the two different ways you can use to understand why we got first order for both. First order है, so we need constant की ज़रूरत है, then you go to, we do need a constant, right?
Yeah.
yeah.
Because rate is proportional to these concentrations. So when you go from proportionality sign to equals to, you need a constant. And the power is your order, but the powers are just 1 in this case. So that's it. State the units for the rate constant K. So rate is change in concentration upon time, correct?
Yeah.
So change in
Yeah.
concentration upon time is
It is.
literally change in concentration
So
upon
rate
time.
will be in moles per dm cube per second.
Yeah, so you have this. This is
S
rate,
minus 1.
and इधर जो scene है, इधर you have mole dm cube दो दफा because दोनों concentration के लिए
So
तो
you
you
have mole square dm minus 6.
say -6. You otherly and you need k, right? So you just take this, you divide it here.
Divide it.
Yeah,
Divide it.
you divide it here. So that makes it mole -1.
Inverse.
-1.
सही है.
dm -3. dm3.
dm3 and s -1.
And
So
S minus 1.
Minus.
yeah. So calculate the initial rate relative value rate of reaction for a reaction where CH3CHO is this and this is this. Say for the reaction, so rate was equals to we don't have a value of K though, do we?
हाँ वो निकालनी है. First you have to figure out K using our values जो पहले दी हुई थी.
Oh, this just for 1 mark. इतने कंजूस लोग हैं मतलब. चलो, sad life. सही है. So पहले अगर आप देखो तो पहले rate 1 is equals to K. I'm just picking values from this what do you call it, from this row, what do you call it, a column,
Row.
0.15. These are just multiplying, right? I don't know, you need to use those brackets. So खैर इसमें से you would get K, which is 0.1 into 0.015.
Do you really need to do this?
So
Lamba method, you just do it like you found out order. That's the way you have to do it.
oh
You don't really need to calculate K.
True. Ratio से भी कर सकते हैं.
True.
Just pick out
Yeah. So like
ratios.
Okay, so let's just compare it to the first column or first row.
or just or Imad, let's go with the third one because third में फिर OH की concentration same है.
No.
नहीं, because first one is convenient. दोनों
Has the most convenient values. Let's just use first one.
हाँ चलो चलेंगे. So like if you compare, yeah, and that's definitely the easier way to go about. Okay.
So the aldehyde concentration is becoming times 3, 0.1 से 0.3 हो रही है.
And we know the order is 1, so we just leave it as multiply by 3.
Exactly. And this is going
that is multiplying by 2, so overall should multiply by 6, which means your
Answer
rate
is
value
6.
over there should be 6.
The relative value of the rate is 6.
so, good scene. Whoa. A 3-step mechanism has been proposed for the reaction in A. कुछ लंबा सा सवाल नहीं है, but okay. So you have mechanism, care, whatever. You have lots of mechanisms. Using your rate in equation in 3, predict which is the rate determining step. explain your answer, and remember the rate depends on both the OH and the aldehyde. Um, so in if you look at step 2, तो step 2 में OH का कोई काम नहीं है, step 3 में भी OH का कोई
Step
काम नहीं
one.
है. Yeah, so it would be step 1 because you have the OH group reacting with the aldehyde. मतलब as products उन दोनों की concentration है, like they're both there as products. As reactants. So
But more important, the more important thing is that you have to look at, for example, in step 2 for CH2COH. If we would have taken step 2 as a rate determining step, it would mean that we would have been actually using two of the aldehydes
Aldehydes
in our
for the
rate
rate
equation,
determining
which is
step,
हाँ, अच्छा,
yeah,
so you have,
which is not the case.
yeah, so in this case you'd
this
have
is not
two,
the case. Just need one.
yeah, you'd have two aldehydes, and both in step 2 and step 3, uh, they're both independent of the concentration of OH because OH to bichara.
No,
Uh,
they're not.
Not
They're not.
really. They are depending on that
They depend
because they're
on
depending
step
on the
one.
previous reaction, right?
Yeah, the previous reaction true, but that particular step is in,
Yeah,
उसमें तो,
Hassan, just move on.
yeah, whatever, sad life, sad life.
The easy way to look at it here is reversible wala slow.
Yeah.
Step 1 has a
Lol,
reversible arrow.
lol, yaar, lol.
That is the simplest way to look at it here.
But we cannot do that because it is said using your rate equation.
सही है. Explanation क्या बता देंगे, both depending on both OH and aldehyde.
It is proportional,
It
huh?
is order 1 with respect to both aldehyde and OH, which means step 1 is the slow step.
That's slow. The rate determining step, yaar.
Same thing.
You can't just call some people slow, yaar. They would
It's
take
not a
offense.
person. It doesn't have feelings. We're gonna say.
Describe the chemical behavior of CH3CHO in step 1.
It is very naughty.
Um. Okay.
Really,
Like,
anyway.
I don't know what to say to that. So yeah, so
In
OH is
step
like
1,
an OH to was the nucleophile. They don't care about that. CH3CHO सब इधर हुआ क्या है?
it,
It has given H positive ion, right?
yeah, so it's acting as a.
Yeah, acting as an acid. Okay, this is a negative sign, right? So yeah, because it's now it's a nucleophile. So since it's donated H positive ion to the OH, which converted the OH to H2O. Anything that donates H positive ion is a acid.
Reducing agent, not acid.
Really?
You can't just call it an acid. It's a reducing agent.
Acidic behavior नहीं कर सकते क्या?
I think.
My life has been a lie. Acid, proton donor, acidic behavior, Imad.
Okay, never mind.
I mean, like, I think वो ना वो Lewis वो जो क्या था पता नहीं कौन सी proton donors, proton
Whatever.
acceptors, like उस चीज से लेके.
Yeah.
Name the mechanism
We
occurring.
thought
Yeah, this is the B1, Bronsted-Lowry. The Bronsted-Lowry acid.
हाँ वो वाला scene. Name the mechanism occurring in step 2 and step 3. Step 2 and step 3 में क्या हो रहा है? एक जगह so the same mechanism क्या? So एक जगह you have this is like basically now a base and then ये तो interesting. I think
Okay, step 2 mein you're getting.
yeah, step 3 में चलो step 3 में it's accepting H positive, which is basic behavior, but they're looking for the mechanism. What is the mechanism here? Is it's attacking the
It's addition. Step 2 is addition.
yeah
Because you're
that's
forming.
and step 3 is also
I think this is nucleophilic addition.
nucleophilic addition में तो यार
Nucleophilic
अली
क्या?
nucleophilic addition में तो this would
हाँ, nucleophilic addition है. Because
Yeah.
the aldehyde double
nucleophile.
bond is being broken, right?
Yeah. So okay. So idea is because this is a nucleophile, and it's adding. Let's confirm this one though. Yeah. So it's nucleophilic addition. So idea was कि if you could या कोई explain कर दे सही से ये
Basically, the
Just saying,
nucleophile
but
is
you know about the reaction about of aldehydes with, if you remember, with CN minus with cyanide. It's actually pretty similar to that.
basically this nucleophile is being added to this double bond, right? So it's a nucleophilic addition.
good scene. Good scene. In fact, that was something I was missing. I didn't realize कि इधर ये भी मसला है ना इधर चलो एक ये है तो दूसरा भी ये है. So I was looking at this thing, but okay.
Yeah.
So use the diagram below. Show the mechanism for step 2, showing the relevant curly arrows and dipoles. Okay, so this is
Right.
slightly negative. This is slightly positive. Say and
Show an arrow.
negative to positive जाता है. So what I guess you just show an arrow like this. Did I miss anything?
Plus that bond breaking, that double bond breaks.
And the double bond breaks.
So that
The
is
elect-
heterolytic fission. So it is like
So you
that.
get this arrow.
Yeah. So like that. And if I remember correctly, homolytic कैसे होती थी ना?
हाँ.
सही है.
Yeah.
A lot of air stuff
Hey.
that is found वैसे यार.
You go from the double bond though for the fission, not from the atom.
Yeah, yeah. Whoop. Good thing. We good?
Mhm.
Some reactions of chromium ions are shown below. Reaction. Use a data booklet to suggest a suitable metal to carry out reaction 1. Chromium इसमें chromium के साथ हो क्या रहा है? तो again H2O तो 0 है. So whatever the charge here is the oxidation state of chromium. So this is 3 positive chromium going to 2 positive. So it is being reduced. So you need a suitable metal, and the data booklet can help you with that. How can a data booklet help us with that?
I think it should be sodium. नहीं.
Sodium. We need a reducing agent. What is a reducing agent?
Yeah.
Nickel. नहीं, nickel इसमें तो use मुश्किल है. I'm curious. Why does it say data booklet? Like, does it mean here?
No, that one क्या कहते हैं? The list of all
The
electrolysis
electrolysis equation.
electrolysis वाली.
अच्छा. Because the idea
chromium
behind
equation.
and the idea behind a catalyst is that it has to be between the E0 values of both equations. So like between minus.
It has to have a high reduction, no?
It has to have a high
High
inert
value.
value so that it can cause the reaction to go in reverse.
Yeah. So the
No, it has to have a lower, na? It has to have a
As in
lower so
more
that it
negative.
can itself be oxidized so that the compound is reduced.
क्या? CS.
क्या chromium की क्या है? It's minus
SN,
0.41.
go to a different table in which the E0 values are listed in ascending descending order. This is in alphabetical order. Go down.
ये वाला.
ये है ना? But इसमें chromium.
हाँ.
Yeah, potassium.
Okay. और
Rest chromium.
इधर तो नहीं है chromium के, but ऊपर हमने क्या देखा था? Was it 0.41 क्या था?
I'll go for potassium.
हाँ पर ऊपर 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 हमने क्या देखा था, क्रोमियम का तो हमें याद नहीं है.
ऊपर तो बहुत सारे ना, the value of it was less than is less than
But the
potential.
chromium value itself is not given in the ascending order
Yeah.
tables.
So we have minus 0.41 and you guys are
And that
saying
was minus 2 point कुछ.
say and we need something that अच्छा you're saying it needs to be more negative ताकि वो नहीं more negative या more positive.
More negative, if it is more negative, then it will be. एक मिनट को. हाँ सही
If
तो
it's
है.
more
If it is more
positive,
negative, then it will be oxidized, and if it is oxidized, then the other product
Huh.
is reduced.
okay, yeah, सही है. So more negative will be oxidized. चलो let's see how correct we are. Any metal with an E naught value more negative than minus good seen. Example, yeah, but rate credit. So I think the example it would normally prefer a like transition, but yeah, it will credit all of that.
It will credit all of them.
Yeah.
It just needs to be less than that of what did we have? Chromium.
Minus.
It just needs to be less than chromium.
हाँ so minus
More negative than
yeah
chromium.
more negative ताकि वो खुद से oxidize हो तो दूसरे को reduce करे. That's the idea. Use E naught values to explain your answer to part 1 by
That we have already done.
calculating E cell. So E cell क्या होता है? E cell is
E cell is basically the difference between the two half equations, right?
it's reduction minus oxidation, right?
Yeah.
Yeah, and if you look at the data booklet, this is
It is
Depending on
minus
whatever you
0.41.
chose.
Chromium is minus 0.41.
minus 0.41.
Chromium is minus
Chromium is minus 0.41. So whichever metal you chose, you'd use that value. So like,
Okay, and potassium ये तो reduce हो रही है, so you just take plus
minus 2.9.
but ये तो reduction की value है. Won't you flip the equation?
You just it'll work it out. Just put it.
आ जाएगा.
Yeah.
So it's minus
Minus
2.92 minus
0.41 plus 2.92.
all right, huh? Plus 2.92, so that gives you
That is a positive value. So yeah,
overall E
this
naught
is
cell, which is a
spontaneous.
positive value, which is why it is feasible.
Okay. But sorry to stop you there, but ये मैं कभी समझ नहीं आता था. तो like why won't we flip the and use a positive sign for what's being oxidized? Because
No, because the formula flips it for us.
That's what you're doing. That's why you're doing R minus O and not R plus O, because you have to flip it. That's why there's a negative in this equation.
अच्छा तो वैसे ही अच्छा the
The
formula.
formula is doing the flipping the sign.
Thank you, formula. Reaction suggested that reaction 2, a student suggested that reaction 2 could be carried out using acidified H2O2. Use the data booklet to show whether or not this reaction is feasible. So you check H2O2 ka. Where is that H2O2?
Which
H2O.
is all the way up there.
Oh, H2O2.
And it is a positive value.
Where did it go? मुझे दिख नहीं रही.
It's
किधर है?
नीचे वाली टेबल में थी.
नीचे टेबल में थी.
नहीं, as in like the one we were looking at पहले.
अच्छा, so
Yes.
yes.
No.
So yeah, and the idea here is that in this case it would be since this is a positive value, so minus 0.41 minus whatever the value was.
Since it's a positive value, it would not reduce it, so it would not work.
it.
Yeah. But feasibility can be shown in another way, right? Okay, if E naught is below 0, if E naught is negative, then does that again is feasibility. We can is not shown. But खैर अगर उसकी value ज़्यादा है, अगर H2O की is more, it is more positive than what your chromium is, तो उल्टा वो reduce हो जाए ये
So then
oxygen.
it's not feasible. Yeah.
Yeah. So the idea then is that but like we wanted to reduce, वो उल्टा ऑक्सीडाइज करने के चक्कर में चला जाएगा, because in fact जो more positive value that reduces, right? Hello.
Mm-hmm. Yeah.
Yeah, so in that case you have chromium minus जो इसी वैल्यू नेगेटिव में है, जो आपका जो ऑक्सीडाइजिंग एजेंट अगर उसकी खुद वैल्यू पॉजिटिव में है तो वो खुद ही रिड्यूस नहीं हो जाएगा, एंड
Exactly. So
chromium
it
को
doesn't,
ऑक्सीडाइज या but that's just like,
because then chromium doesn't get reduced, so it won't be feasible.
सही है. पर क्या था ये BM1 you show, okay, so you have to pick these equations वैसे. Ah, lol. So reactions.
Is that?
Khair, sad. Let's try to figure out what we did wrong. Maybe probably picked the wrong equation. ये तो H2O2 है ना इसमें, H2O तो नहीं अच्छा नहीं.
I think.
We can pick this one, and in fact that would be more relevant. Here there's H2O2 on the क्या कहते हैं in the product side. But how would we know कि कौन सा वाला pick करना है हमें?
A second. The student.
Acidified hydrogen.
Acidified.
Whoa. Okay, that makes sense.
And
So
we're talking about reaction 2 here. We want to oxidize it.
No,
Whoa.
it's just
By the way.
acidified, and that's your clue.
yeah, so that's acidified. That's why you know that equation to pick. And yeah, they're talking about reaction 2, where its chromium is going to chromium की क्या होगा? This is -14, and ये जो भी आएगा it has to be
It's going
minus
to a +6.
+12
right?
होना चाहिए. Yeah, so this will be +6.
So it is getting oxidized,
Yeah, so it is getting oxidized.
which means the reaction is feasible.
Yeah, ऐसे properly करना पड़ेगा, लेकिन there are a lot of query, lot looking at the data for this. So yeah, so you have this reaction is plus 1.77, and if you look at chromium in, because again now we pick ये वाली equation, now that we know that we're looking at reaction 2, not reaction 1. That was a silly mistake on our part. So yeah, so chromium is being oxidized because it's not, because obviously जो हमारी पहली equation थी, that was more positive, that will be reduced. So now you have 1.77 minus 1.33, and that's all you need to write to show the examiner, you know. So 1.77 minus 1.33, I believe. जो भी value
Is
आएगी,
positive.
idea is positive. If it's positive, if E naught,
So it's feasible.
yeah. Say, explain using oxidation numbers whether or not reaction 3 is a redox reaction. So
Now reaction 3
let's
is
just clean up a bit. So इधर हमने chromium का we figured out it was +6 before. And if you look here, so overall 2 negative है. Oxygen will give you -8 because oxygen का हर -2 है. That is for sure. And overall 2 negative है, so chromium has to be +6, which is fine because there's one atom of chromium and that's +6. So it shouldn't be, it's
since there's no change, so
Yeah.
it's not redox.
So no change.
in oxidation numbers, so no redox.
Numbers, not redox. Right. Okay, so the student used an acidified solution of C2O7 to electroplate a steel box with chromium metal. Calculate how long it would take for a current of 0.125 ampere to deposit this much chromium metal. सही इसमें is it the linking to वो जो था gram equivalent deposit जो था, so when 1 mole of electron goes through it you deposit जितना आपका the mass, the MR number in grams basically, unless I'm
Basically, you deposit 1 over that many moles of metal.
yeah, so if it was 1 mole of electrons passing, chromium would give off, where is chromium? 52. Is that a correct way of looking at it? 1 mole of electrons would give off 52 grams of chromium. Hello?
एक second, equation क्या है इसकी? Where's the chromium equation? So that takes 9 moles of electrons to deposit 2 moles of chromium.
How can you tell?
Because you have from the two equations we have Cr2O7 going to Cr3 plus, right? That's using 6 electrons, and then Cr3 plus going to Cr metal, that's using 3 electrons more. Oh wait, right. So it's 2 of them, so it's 12 electrons for 2 moles. So you need 6 electrons per Cr, right?
Okay, so you need 6 electrons to
Per moles of Cr,
deposit,
because Cr6 plus is metal पे जाना है, right?
yeah, no, so वैसे तो you would 6 into 6 moles of electrons, yeah, basically to deposit 52 grams of chromium. If you want only 0.0312 grams of chromium, you would need X moles of electrons. So you just cross multiply. So the idea here is X moles of electrons would be 0.0312 into 6 upon 52. Correct me if I do anything wrong.
Yep, that is fine.
So yeah, so these are the moles of electrons, and Q is equals to IT, Q is equals to IT, and Q is equals to NE. Right?
Yeah.
So
And we need to find out.
you need to find T. N is the elementary charge, which is
N
one.
is
Which is N is the charge of one
is
one electron.
N is not the charge of one electron. E is the charge of one electron. N is the X we calculate.
Okay, so N is the number of electrons, E is the charge of one electron. So you take the number of electrons, which was X, जो हमारा by the way आया था 3.6 into 10 to the power minus 3. I'll just write it 3.
That is moles, right? So it's go multiply by Avogadro's number.
Oh yeah, and we got this many moles of it, so we got 6.02 into 10 to the power 23 to get total number of electrons, 6.02. So yeah, which gives us 2.1672 to 10 to the power 21. These are the number of electrons, and you
Then you
now
plug it in the formula and
plug it
find
into the formula into 1.6 into 10 to the minus 19 divided by I, which is